Hey students, today we're going to talk about redox reactions, and you're going to write balanced reactions. So steps to writing balanced redox reactions, and these are only going to be spontaneous. I know you don't quite understand that now. Next folder, you'll understand what I mean by spontaneous redox reaction versus not spontaneous redox reaction. So we're going to reverse the reaction that has the lower standard electrode potential. If you remember from the activity that was previous to this folder, that in order for the reaction to occur, the anode had to be the lower one, so the one that was being oxidized had to be lower. And so this is why you flip it, because all of these reactions, those are all reduction reactions, because the half reactions are gaining electrons, and so since we need the lower one to be oxidized, we have to flip it. Number 2 is multiply each reaction so that the electrons will cancel out, and then write the balanced reaction. So we're going to go through 2 examples. So we're going to, and this is exactly what your worksheet will look like. It'll be exactly what your test will look like for this type of stuff. So you want to write balanced reactions for a spontaneous reaction using the reduction tables given. So if we've got these 2 reactions, so we've got 0.54 and 0.16. Do watch, because I might not always put the larger value on top. But this is the smaller value, so we need to flip. We need to flip this one. And then look at the number of electrons. We have 2 electrons here, and we only have 1 electron here, and we need to make the electrons be equal. So we're going to times this reaction by 2. So now what I do is I rewrite all the reactions. So we didn't have to do anything to this reaction. So I am just going to write this reaction the exact way that I see it. And at this point, I don't care if you use a double-headed arrow or just an arrow. You guys are probably more used to just the arrows, so that's fine with the arrow. And then this reaction we have to flip and multiply it by 2. So flipping it means whatever on the right-hand side will now be on the left-hand side. But we need to times it by 2, so we're going to have 2 of those Cu pluses. And do make sure you pay attention if it has a charge or not, because those are important. And then we'll do the arrow, because that came next. And then these 2 that are on the left-hand side will now be on the right. So we'll need 2 of those Cu2 plus, and we'll have 2 electrons. Now you'll see that we have 2 electrons on the left and 2 electrons on the right, and so those will cancel out. And then what we have left over is whatever is on the left-hand side, write that, then draw the arrow, and then whatever's right on the right-hand side. So we've got I2 on the left, plus 2 Cu plus, going to an arrow, and then we have 2I minus, and 2 Cu2 plus. I don't care what order you put these in, because 2 plus 3 is the same thing as 3 plus 2. So you could have had 2 Cu plus on over here and I2 over here. Same thing over here. Big thing is you have them on the right side and the right amount. You have the right charges. You have the right subscripts. Okay, you should pause the video and see if you can do this next one on your own. Okay, I hope you paused. So we need to figure out which one has the smaller value. Well, on a number scale, a number line, the negative 0.76 is smaller than negative 0.04, so we need to flip the top one. And then look at the electrons. We have 2 electrons here and 3 electrons on the bottom. So we need to make them even. So we're going to times the top one by 3 and the bottom one by 2, so that the electrons will cancel out. So they'll each have 6 electrons. So we're flipping the top reaction, so that means zinc is going to be on the left-hand side, but we also multiplied it by 3. So 3 zinc, I'll make this look like a Z by putting a line there. Then we have the arrow, and then we've got Zn2 plus and the electrons that are now going to be on the product side. And we multiplied them by 3, so it'd be 3 zinc 2 plus, and then 3 times 2 would be 6 electrons. Then we don't have to flip this one, but we do need to multiply it by 2, so we've got 2 Fe 3 plus 2 times 3 is 6 electrons going to 2 Fe. So on the top we have 6 electrons on the right, 6 electrons on the left on the bottom one, so those cancel out. And then write what you have left over. So I see 3 zinc and 2 Fe 3 plus on the left of the arrows, and then I see 3 zinc 2 plus and whoop, and 2 Fe on the right.